Hi guys, back to Miss Wesley here, and here we are for Unit 2, Skill 5, and this focuses on angles and a parallelogram, and there's a lot of different properties about a parallelogram that we are going to learn about throughout the course of this year, but we're going to touch on just some of the more important ones that help you to determine missing angles. So take a second and jot down your essential question for me here. Alright, it says, what are the properties of a parallelogram that can be helpful in finding missing angles? So like I said, there's a lot of parallelogram properties, but we're just going to focus in on 3 of them here that are key in finding missing angles in a parallelogram. So take a second to jot that down. So like I said, our focus for today is going to be around parallelograms. And you might know some properties of a parallelogram already, but we're going to talk about 3 of them here. The first one says opposite angles, so angles that are opposite from one another in a parallelogram, are congruent. And if you think back, congruent means they are equal. So opposite angles in a parallelogram, so essentially the angles in opposite corners, are going to have equal measure. Then if we talk about adjacent angles, so remember adjacent means angles that are next to each other. These angles are actually supplementary. And remember that means that they add up to 100. Let's make that an 8. 180 degrees. There we go. So opposite angles are congruent, but angles that are next to each other have to add up to 180 degrees. But then this one focuses on opposite sides. Opposite sides in a parallelogram are officially parallel, hence the name parallelogram. And because they're parallel, if a diagonal line is drawn, similar to what we have in this example 1 down here, it's going to form alternate interior angles. Try to go back, make that an A. Alternate interior angles, and again remember that those angles are also congruent or equal. So we're going to take look at a couple of different examples here, and we're going to start with example 1. Example 1 says the diagram below shows parallelogram LMNO. So as soon as I read that, I'm going to think back to these properties that we talked about up above, with a diagonal LN that's drawn in. And it gives us 2 angle measures. Angle M is 118, and angle LNO is 22. Both of those are already labeled for us. Our goal here is to explain why, so again, that means we're going to have to write a sentence or 2, why angle LNM is 40. So this problem is actually telling us what the answer is. We just have to explain why. So I'm going to take a second and first find where this angle actually is. L and M. So if I follow that with my pen, L to N to M, again focusing on that middle letter there, my goal is to figure out what that angle down there is, but again I know it's 40, we just have to prove why. So here we go. We know it's a parallelogram, so we know these 3 things up above are true, but notice that this parallelogram is essentially split into 2 triangles right now. So if we focus on this triangle right here, we already know one of the angles is 118 M. It told us that. We know the angle we're looking for is going to end up being 40, so it'd be really helpful right now if I could figure out what this angle up here is. But again, we said that opposite sides in a parallelogram are parallel, and that's what those little arrows there stand for. And this 3rd bullet up here said if a diagonal is drawn in, you're going to get alternate interior angles. So how this angle down here in the bottom right is 22 degrees, that's going to also force this angle up here to be 22 degrees because those are alternate interior angles. And since we didn't know that before, we have to jot that down. So let's take a minute to write that as a sentence. So our first thing here that we discovered is the measure of angle. I'm going to call that angle MLN is equal to 22 degrees since opposite sides of a parallelogram are parallel. But that wasn't the only reason we knew it was 22 degrees. That was the first step in getting us there. So since opposite sides of a parallelogram are parallel, that allowed us to say this statement up here. Alternate interior angles are congruent. So we have to finish our sentence with that. So MLN is 22 degrees since opposite sides of a parallelogram are parallel and alternate, that should have been T, alternate interior angles are congruent. All right. So that allows us to say that this angle up here is also 22 degrees. So now if we go back and look at that yellow triangle we have, we now know 2 of the 3 angles. So our last step then is to figure out what this angle down here is. But since it's a triangle, we can use our triangle property that says all the angles in a triangle have to add up to 180. So if we do that little bit of math off to the side, 180 minus the 118 minus the 22. Again, you can take a second, pause, type this in your calculator. But what you're going to end up figuring out is that third angle down there is going to have to be 40. And that's what the question said. So we just have to summarize that now in one final sentence. So we can start by saying the measure of angle, and again I'm just looking back up here at what it told me. LNM is equal to 40 since angles in a triangle add to 180 degrees. And that's the end of our problem there. So again, something with these explain why questions, and Ms. Griffin has probably said the same thing, a lot of times students just want to explain the last step. So for instance, they would just write this sentence, they wouldn't write that first sentence they have there in purple. And in order to get full credit, you have to explain each step along the way of how you got to your answer. So make sure you have both of those sentences there. Again, anything you're not sure of or don't understand, put a question mark by, call your teacher over, and we will hopefully explain it for you. But I'm going to take a look at example 2 on the next page. So once you're all set with this, flip over to the next page, and I will see you there. All right, so here we are, example 2. Given the diagram below, where triangle ABC is equilateral. So as soon as I read that, that's a vocabulary word that we've already talked about. It's something that's definitely going to be important to this question, so you want to make sure that stands out to you. And it also says BDCE is a parallelogram. Explain why, so another one of our favorite kind of questions here. Why angle BDE is 120. So just like I did last time, I'm going to take a second and mark that on my picture so I know where I'm eventually looking to get to. So again, follow it with your pen, B to D to E, and focusing on that middle letter. So our goal is to figure out why this angle over here has to be 120 degrees. And I'm just going to write that off to the side. 120 degrees. So let's first go back and focus on the fact that it said our triangle ABC was equilateral. If you think back to equilateral, that means that it has to have 3 congruent angles. That should be an E, angles. Well, if all the angles have to be the same, and I also know that all the angles in a triangle have to add up to 180, if I take 180 and divide it by 3, I'm going to figure out that each of those angles is going to be 60 degrees. So I'm going to take a second and jot that down. So each of these angles here is going to be 60 degrees. So we can go ahead and write that in. 60, I'm probably just going to write it once here because I won't have room on my iPad. But make a note to yourself that all those are the same length. Sorry, the same measure there. Each of those angles are 60 degrees. And again, we didn't know that to start, so that's going to be our first sentence that we jot down. So because we have 3 angles here, and we can't call them each A, B, and C, because again, B could mean 2 different angles and C could mean 2 different angles, we're going to be really specific in our sentence here. So we're going to start off by saying the measure of angle. Now I can just say A to represent this angle right here, because that's the only angle I have. But then if I go ahead and talk about angle, that top angle in my triangle, I'm going to call that the measure of angle AB. BC. And then my bottom angle down here on the right, I'm going to call that the measure of angle ACB. Again, focusing on that middle letter there, are all 60 degrees. Since, and again, we go back to how we figured this out, it was that key vocabulary word up there, since equilateral triangles have 3 congruent sides and angles. And again, we also have our math off to the side over here that helped us to figure out what each of those actually were. This should have been congruent, if I can get my squiggly. All right, so we know each of those are 60, and now we're still trying to get to our goal of figuring out why this angle over here is 120. Well, the next thing we can look at is we know that this angle down here, the left side of C was 60, so we can figure out what this angle on the right is. Because again, these two angles are sitting on a straight line. So think back, angles on a straight line have to add to 180 degrees. So if I do 180, take away the 60 from the left side, that's going to force the angle on the right side of C to be 120. And again, I didn't know that before, so let's jot that down as our next sentence. So that angle I'm going to call BCE. If you call it ECB, that's also fine. So the measure of angle BCE equals 120, since angles on a line equal 180 degrees. So we now know that that one angle there is 120. Our goal, again, is to figure out why this angle over here is 120. But now if we take a step back and focus on the fact that the question said we have a parallelogram from B, C, E, and D, well, we would consider this angle down here that we just figured out, that 120, I'm trying to get a color here that we haven't. This angle was 120. Well, this angle would be considered an opposite angle with angle D. And if you think back to the first page, we talked about how opposite angles in a parallelogram are congruent. So since this angle down here in the bottom left was 120, it's going to force angle D to also be 120. So that's what we're going to talk about in our last sentence. So the measure of angle BDE is 120, since opposite angles in a parallelogram are congruent. All right. So again, pause me at any point in time here so you can jot everything down and process what I'm saying. But we took this problem one step at a time, and again, we focused on the vocabulary that was given to us to help us through the problem. And each thing that we figured out needed its own sentence to justify the math that we were actually doing. One last example here. So it says parallelograms ABCD and AFCE. So notice right away we actually have two parallelograms built into this problem. There's a diagonal AC drawn in, and it tells us that angle D is 38, which is already labeled, and AEC is 53, which is already labeled. And we have two congruent sides, AB and AC, which you can see by the little red tick marks. Determine the value of T. So that is our goal. It just says determine, so we don't have to explain here, but we do have to figure out what T actually is. So you might be looking at this and say, how are we going to figure out what in the world T is? There was a lot of information given to us, and you're right, there was. But if I go back and again start with the fact that it says we have a parallelogram ABCD, I'm going to stop there. I was about to go through the whole alphabet. So if we follow that, where's my pen? A, B, C to D, and I connect back. Notice that this angle over here, this 38 degrees, well, that would be an opposite angle with angle B over here. So since D is 38 degrees, that's going to mean angle B is also 38 since opposite angles are congruent in a parallelogram. So I'm going to jot that down. So this angle right here is 38 degrees. Well, that's not T. So let's look at another shape. All right. Notice that I have those two congruent marks. Ignore my phone ringing in the background. So A to B to C. So this triangle is actually going to help us to figure out another angle because remember the question told us that AB, this piece right here, was congruent to AC. So that would mean that this green triangle I just outlined as isosceles. And thinking back, isosceles triangles have two congruent sides, which means they also have two congruent angles. So angle B was 38. Well, that's actually going to also make this angle over here be 38 because those are the two angles opposite of the congruent sides. So I'm going to jot that down, that this angle over here is also 38 degrees. So this angle, the one that I just found, maybe you can hear that thunder. So that's 38 degrees. Well, I'm still trying to find angle T. Well, now there was another parallelogram that the question told us about. The question said AFCE was also a parallelogram. So if I follow those letters, AFCE, that's another parallelogram. And that green line, A to C, is a diagonal in that parallelogram. And thinking about the first example we did, if you have a parallelogram, well, you know that alternate interior angles are going to be congruent. So that 38 that we just figured out is actually also in another spot in our picture. So this angle over here is also 38 because these two angles would be considered alternate interior angles since opposite sides of a parallelogram are parallel. So I'm an angle closer to finding T, but it would be really nice if I knew what this angle over here was, because then I could look at that triangle and say, okay, well, triangles add to 180, so I can find T. Well, we haven't used that 53 yet at all. And take a look. This angle that's 53 over here would be considered an opposite angle with that angle that I'm trying to find. And since opposite angles in a parallelogram are congruent, this angle over here is going to be 53 degrees as well. So with that information, we can now focus on that little triangle. Let's pick a color I haven't used yet. This triangle here, AF to C, because I know this angle up here was 38, I know this angle over here was 53, so now in order to find T, we just got to use our 180 trick. Right? It's not even really a trick, it's a property, I should say. So, to get T, we have to take 180 minus the 38 degrees minus the 53 degrees. And if we do that, we're going to figure out that T is equal to 89 degrees. So that was a lot of work there to get angle T. Thankfully, we didn't have to explain because that would have taken an entire paragraph on its own. But it's one of those that you really just want to keep fighting through the problem, look at the different information that was given to you, use your highlighters, your different colors, focus on that given information like sides being congruent or the fact that you have two parallelograms, because all of that is crucial to figuring out what the problem's actually asking. So take a minute, look through these notes. I would definitely keep them open to the front page so you have your parallelogram properties to reference, and then get working on those practice problems, and then when you're ready, take that CFU after you've written your wonderful and lovely summary. Till next time, see ya.